Hello everyone and welcome to class of Voice over LT Technical Summary. So let's discuss about Voice over LT. So Voice over LT delivers voice with high quality of service, which is quality of service 1, guaranteed bitrate and EPSP error. So this in transport and radio scheduling, but admission and congestion control may be efficiently used to preserve the voice quality experience in presence of high traffic loads. So non-guaranteed bitrate EPSP error like QCI5 are used for SIP and XCAP. XCAP is also a protocol which is XML role application protocol. So in a line network, voice domain selection is IMS packet switched voice, which is preferred over circuit switched voice, and circuit switched voice is secondary in nature and preference of packet switched is first. So voice over LT can provide base telephony service and other supplementary services, and it could be used like we can use UT and XCAP procedures. So the voice over LT bearer management, which includes PDN connection for IMS APN, signaling bearer setup, PCSCF discovery, home routed PDN connection, APN for UT, handling of loss of PDN connection signaling and guaranteed bitrate bearer. IMS feature part, which includes ISIM based authentication. Here we can have USIM fallback, IPsec protection of signaling. IMS media, which includes AMR narrowband and wideband codec as well as payload format, RTP profile, data transport, RTP usage and jitter buffer management. Here we can have SMS, which include SMS over IMS and SMS over serving gateways. So what is voice over LT capability in UE? Like UE indicates its EUTRA capabilities in the UE EUTRA capability information element, which is at the connection setup. So we call it RLC UE capability information messages. We can have feature group indicator, which indicates functionality. Those are supported by UE. Now further in this we can have VoIP video quality of services and features. Like introduction of VoIP, which possesses a number of challenges over LTE access network. So in order to make VoIP attractive for the commercial deployment, the capacity was also desired to be either comparable or more than that of the legacy circuit system. So to provide the quality of circuit switch voice without excessive degrading the system capacity, end-to-end quality of service support in the wireless and wireline packet network infrastructure is totally essential. Know that voice is sensitive to data loss, but robust coding and well-functioning error concealment unit which make voice more tolerant to data loss and other media types. Like voice is very sensitive to delay and jitter. Similarly, video telephony is very sensitive to data loss. Video telephony requirements on frame errors are almost a factor of 10 less than for voice. SIP signaling, XCAP, which is XML configuration access protocol, and other signaling must be error-free for transaction to be successful. There are TCP and SIP retransmissions. These are the mechanisms that guarantee the data transfer become error-free. Policy and charging control, which enables quality of service supervision control of media parts of SIP session. PCRF support PCC procedures, which make policy and charging decision based on the total input from the user subscription information. Voice codec, like what are the codecs we are using for voice in a video? So possible codec for voice EVCR A, B, AMR wideband, tandem free operation and transcoder free operation supported in IMS code for circuit switch interworking. We can have speech latency requirement, which is no more than 150 is preferred, and packet loss is 1%. Coming to the video codec, So in video codec, we are recommended one is H.264. Here we have standardized 3GPP has standardized QCI1 for transmission of voice RTP packets and QCI2 for the video RTP packets. These are triggered on PCRF on demand. So radio bearer for voice over LT. For voice over LT PDN connection, we call it as EPS session, which handles flow of the IP packets. Those are labeled with UE IP addresses between the UE and a PDN. Access point name. EPS bearer is a pipe through which IP packets are delivered over the LTE network between the UE and the PDN gateway. UE can have multiple EPS bearer concurrently, like we can have 11 EPS bearer. The EVI range is 5 to 15, which is allocated by mobility management equipment. Now RLC UM, which is unacknowledged mode. There are RLC services, RLC functions. RLC functions are performed by RLC entities. Now RLC entities are configured to operate in TM, UM and EM mode. Like what are the functions? RLC function like concatenation, padding, data transfer, error correction, E-sequence delivery, in-sequence delivery, duplicate detection, flow control, RLC re-establishment, protocol error detection, recovery. So this unacknowledged mode, where AM has acknowledged mode and transmission mode, with unacknowledged mode, like it provides unidirectional data transfer without sending any feedback to the transmitting entity. Therefore, no retransmission of packets are there. So these are mainly utilized by delay sensitive and error tolerant real-time applications, especially VoIP and other delay sensitive streaming services. This mode as RLC UM is useful for services that tolerate a higher packet loss but require lower latency. Thank you so much.